This is a quick intro to Sed, the Unix/Linux command line stream editor. Lots of examples going from very simple to some pretty significant usages. Anything beyond this, probably want to think about using Perl or maybe Python. So first of all, let's see. We've got a simple file, cat. Okay, this will be our example file. If you want to change something in it, you say sed, and then in single quotes or double quotes. So you put a substitute. All the things that I'm going to do, I use substitute. I think there's other options, and sed's tremendously powerful. I just use the S. And then it's from to. And so say we wanted to change all the zeros in this file to, I don't know, underscore. And there it is. Except you can see, it only changed the first occurrence. You want to change more than the first occurrence, hit the G option, which then changes like global. It changes every occurrence. So here you can see all the zeros got changed. It's a stream editor, so it's usually meant to like run in a command sequence. So if you haven't seen that before, say you can do a cat on say blinky, and then you pipe it with a vertical bar into the next command, which could be sed, and then you don't have to specify the file in that case after you've specified it at the beginning of the stream editor, at the beginning of the command string, and you can hit an enter, and it gets the same result. Let's see. G is an option that you can put at the end. There's another option. So let's say we wanted to replace all the F's with underscore. Why not? And it did not do anything because we have capital S. So you can put a case insensitive there. Add the I for case insensitive and return. And so those are the two main options I use, like the global to replace everything, like on the complete line, and also the I for case insensitive. Let's see, what else we want to hit here. Oh, oh. All right, so one other slight variation. So we're using these slashes here. Like, I guess that's the forward slash. You can use any delimiter you want to. So sometimes if your string that you're working on has a slash in it, maybe you want to use a different delimiter, such as maybe like the pound sign. So now we repeated the pound at the beginning, middle, and end, separating the from the to, and hit return, and same result. Let's see, stream, options G, options I. So like like you said, it's usually used in a stream. So here's kind of an interesting use case, which I use to create these notes. Is that I use the history command. So I was practicing. So I created a bunch of history, got a lot of stuff here. And then I just pipe that into the grep command. Pipe is the vertical bar again. And I looked and I said, grep finds any lines that have a string in it. So grep sed. So now I've got all the lines with sed in it. And then I got a lot of these line numbers that I didn't want. So I pipe that into sed tick. You can see I usually start off, with a template of the uh, single quote, S, 3 slashes, and a single quote. Then I fill it in. So in this case, let's see, I got a lot of cat commands things starting with that. So you don't need to understand this yet, but like we can do space, star, cat, cat. Will that work? I think that should probably work. Oops. Star. Yeah, try that one. And now you got a bunch of these commands like these cats, and the line number's been removed. And then I basically got that, popped it into here, and cleaned it up a little bit. So often you're not looking for perfection with a sed. You want to get it close so that you can do minimal editing on it. Sometimes you get it perfectly spot on, and you're very proud of yourself. But if you're looking for perfection, again, I'd probably look at another scripting language to just take care of it, deal with error cases, things like that. So where we go? We got commands. Oh, so wildcards, those are cool. Um, so we got two different wildcards. One of them which matches 0 or more occurrences, and another one which is a star, and another one which matches 1 or more, which is the slash plus. So say let's cat blinky. Say we wanted to match one or more the say you wanted to match um, one or more of like the 0. So that pipe that into sed tick G for replace all of them as a 0 star. And replace that with like an underscore. Let's see what we got. Oops, mad at me. Oh, I didn't follow my template. And so you can see that it replaced here at the beginning, which didn't have any zeros. That's a little confusing, but then we have a string of 4. It replaced that with a underscore. So it replaced these 4 zeros with an underscore, and it popped the 5 there. Then it didn't find anything, so that's a match. So it put an underscore in, and it didn't. So that's a little confusing example. You can maybe get a better one, but just know that star matches 0 or more occurrences. And that 0 is kind of making it look a little bit bizarre. If you do what's this, a backslash plus, hit an enter key. And now, let's see, let's get the original up and do that command again. So you can see that we have a 4. Those 4 zeros got replaced by an underscore because we're matching out 1 or more. Here on the next line, we got 3 of them, which became an underscore. Then we got the 5, and we got a single 0, which became an underscore. 5, 1, 3. And then we got 2 zeros, which became an underscore. Then 1, and then the next 2 zeros became an underscore. So you can see that the star matches 0 or more occurrences. The slash, the backslash star matches 1 or more. You can see that when you use the star, which is more commonly used because it's a single character, it can give you some bizarre results as we saw. So just be careful of that. And, And I'm not saying don't use the star. I use the star quite often. So that's repeating wildcards. Now, just general wildcards is that match anything. Why we have two examples of it. Okay, so say we wanted to, in this case, match anything. The dot is a match, a period is a match anything. So we want to match anything and change it to, let's call it the match anything to plus sign. What you can see is it replaced the first character of every line with a plus sign because it was matching the first character. And if you want to change everything, put the G in, which will match and continue on, and it's not limited to just one per line. And everything becomes a plus because everything matched the dot. Match anything here. A wildcard on another one. If you're looking for just white space, or maybe we should call it space, so it's less confusing here. Let's change it to space wildcard. And so space is like the space or a tab, and so it'll match anything that's a space. And so in this file, we don't have any spaces. So let's go in and Sed S boom G boom. Let's change. I don't know. Let's change 5 to a space. And then what we want to do is let's see if 0 is better. That's a lot of spaces. Okay, so that's changing all the zeros in the blinky.hex file to a space. So now we've got a space so we can do an example. So we're going to pipe that to yet another pipe of sed. And so a common thing is to do where you're looking for any number of spaces and you want to convert those maybe into the letter R, but just for no other reason. So you can see now we have all those spaces. We're going to change any number of those spaces to the letter R. And you can see that all those spaces we got turned to the letter R. So that's just so the /s is a wildcard for space. And then if you never use tabs, you could probably get away with just putting a space character there. Oh yeah, it's kind of interesting. So that was a space. I guess this is probably even more interesting. So we got those spaces there. And if we went and we made this instead of a lowercase s, made it a capital /s, that means anything that's not a space. It's a common paradigm. Lowercase is when something is something, and the uppercase is when it's not. And so now we're looking for anything that's not a space, and we're going to convert those to the letter G, R, U. I don't use that very often. So all these numbers that we see over here, all those should turn into U's because they're not spaces. Let's see if that happens. Oops. Not bad, huh? So if we got rid of this, still you got the slash capital S. That might be a little clearer for you because we were changing any number of not S's, and now we're just changing individual characters. So it's kind of cool. Similarly, let's go back to this example here. You have all those. You have a wildcard for so the slash W is any word character, which are letters and numbers. Oops, messed up. With the pipe vertical bar. So the slash W we changed to Q's. So every alpha num got replaced with a what I asked for here, in this case Q. And then you can do the reverse of that, where you can do a slash capital W, which is everything that is not a word. And that should make it so that all these numbers stay, but all the spaces become a Q. Yep. All right. And then digit wildcards. So like Perl and Python. So Python leveraged Perl's regular express capabilities and followed quite a few of the conventions and of Perl, and so they're very similar. But those have a slash D, similar like the slash W for word and slash S for space. They had a slash D for digits. Sed it does not support that. So in order to get to find numbers, actually we could just go straight with Blinky here. So we're going to replace all the numbers with something. Sed tick S G and so in this case, a square bracket, close square bracket, and stuff that goes into this square bracket is a grouping of like it's a character group. So in this case, we could do 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. It's a lot of typing. So they do allow you to do 0-9, which is everything from 0 through 9. And we're going to replace those with N for number. And so you can see all the numbers became N, like the C, F, E, E, D's, all those stayed the same because they're not in this grouping. So that's how you would find and change letters. One last one that's kind of cool is this is what the starting point is, and you put a little up arrow, the caret symbol, at the beginning, right after the square brace. Now that means not. So everything that's not in 0 through 9. So that means all of the letters, like the A, B, C, D, E, F's, should change to N. And so you got these little N's down in here, N's up in here. So that's a good way to get not something. Anchors. Nice. Okay. So this common thing that I do is sometimes I want to put some like prefix on a string. So say I pipe that into sed tick s and that little up arrow. So this is not in the square braces, so it's out by itself. And that up arrow means that it's the anchor for the beginning of the line. Similarly, the $sign is the anchor for the end of the line. So here at the beginning of the line, I want to say, begin, start, comma, right? And now we got something, start, comma, at the beginning of every line. Similarly, say you wanted to put end at the end of every line. That $sign is the anchor for the end of the line. And return. And now it's putting the text end at the end of every line. Sometimes I want to put something at the beginning of the line and the end of the line. So I'll do something like that. Then I'll pipe it into and now we've got something at the beginning of every line and the end of every line. There's other ways of doing that, but that's cheap. That's one way that's easier for me to remember. So those are the anchors. And also similarly, you can use the anchors to change text at the beginning and the end of the line. So let's see. Say you wanted to change everything that started with a letter to underscore. So at the beginning, bang, S/G. And you don't have the G, crank. Doesn't hurt. Everything starts here. F. Do /W for word. So anything that starts with a letter, we're going to replace with a sign. And because words are alphanums. So if you just want letters, geez, what do? Create our own character class. A-C. Oops. See, right? Go. And now you can see that where these were F's and F's, the beginning of the line, we've now changed those to equals. And you could do something similar. Let's say everything that ended with a 3. You want to say, go in and change this to like 3 $sign. We can change that to, I don't know, a cult. It's got the dollar sign and anchors it to the end of the line. So any threes that are sprinkled. So you changed all the threes at the end to colons, but here's a three that show, and here's a three that shows that they weren't at the end of the line, so they did not get changed. Um, nice digits, anchors, word boundaries. Oh, word boundaries are kind of cool. Let's get that example again where change plus zeros to spaces. Didn't work so well. G. Yeah, that's a lot of those. Um, so we got to do a word boundary. I'm trying to figure out a good example. So we got the 5-5 in here, the 6F in here. So that pipe said to S G. So this backslash B means like the beginning of a word, end of the word. It's not a character. It's a boundary. So it's smart enough to know that the previous character was not part of a word. So it could be the beginning of a line, um, or it could be a space. It could be some other of the funky characters. Similarly, at the end, the slash B means it could be the end of the line, or again, space, or one of the other bizarro non-word command characters. And now, let's W star. So we want everything complete words. So this is what we're looking for: is we want complete words, and complete words we want to change to call it dollar dollar dollar. Go. And so what happened here? We changed this 4 to dollar dollar. We changed this 537 to dollar dollar. We changed this 5 to dollar dollar. We changed this 531 to dollar dollar. So all the words, the complete words, bounded by this slash B with a word in between, got changed to something. In this case, dollar dollar. So boundaries. Okay, it's got a choice. So let's go back up to here. And so we want to, in this case, we want to do this alternation thing. So we want to choose if it's A or B, then do something. So in this case, it's a slash, backslash, parentheses, backslash, parentheses. I do. What happened? Let's do this again. Pipe sed take S G boom boom. There we go. What are we gonna do? Yeah. So we want to do if it's A or B. So it's a choice. So it's backslash, open parentheses, backslash, close parentheses. Go to the middle of that. It's backslash. What do I do? There we go. And then it's backslash vertical bar. It has to be a whole, isn't it? Um, Sometimes people say regular expressions are a read-only language. I mean, a write-only language because you can't read it after you've done it. So anyway, here we are. So inside that, say we have an occurrence of, we want to find 50, and the occurrence of 50, and trying to see, we've got multiples here. We got a few FEs and a couple 29s. So if we have an FE or a 29, and we want to change those to JJ. All right, so here's the JJs, the JJs, the JJs, and you can also type it to grep JJ, and you can see that there was four lines that were modified with those JJs. All right, so that's a choice. Captures. It's kind of cool. So the captures I usually use when trying to morph the line. So in all the previous examples, the line pretty much stayed the same, except for a few changes. Now we're trying to significantly morph the line. And that's when we start using these captures come in very handy. And so that capture is done again with the backslash parentheses, and then you reference it with the backslash 1, 2, 3, 4, 5, backslash 1, backslash 2, backslash 3 for each capture that you have. So say we have, I mean, this is a good example. This out. Okay. We want to change things. So okay, so let's say we want to ignore the first two letters. So up arrow. We did mention earlier that the dot is so the up arrow is the caret, which is the anchor for the beginning of the line. We did mention earlier that the dot is a wildcard for anything. So that's two characters. And now then slash parentheses slash close parentheses. Get the next two characters. We want to capture those, say they're important. Let's do that again. Get the next two characters. And then we want to ignore the rest of the line. So all we want to do is get the first and second we ignore, the second and third we want, the fourth and fifth we want, and then we ignore the rest. So to ignore the rest, dot star. So that ignores the rest. So that'll take it and match everything to the end. So that's essentially matching the entire line. Now we want to replace it with /1 space. Let's see, I'm going to say, how about this? If parentheses /1 space equals /2. That. So I thought I couldn't have parentheses. Hold on. There you go. So you can see that the second and third letters, I mean, first, second, third, and fourth letters are here. Fifth and sixth letters are here. So 0005. First two characters were ignored. 0505. And you've almost got yourself a little almost program. So that is how you can capture characters, matches, and put it into the result. Yeah. And then let's do this one. Copy. So I call this my opus. So this is what got me on the journey of regular expressions. Seds. I'm playing around with seds the other day. Is that I had Blinky, and I wanted to convert Blinky into this. So I wanted to assign, these are essentially, it's a format called readmemh. It's part of Verilog. It's not important, but essentially each line is an address in the memory. And so in Verilog, you want to prefix a hex file, a hex digit with 32 tick H. A tick X this single quote. And then I wanted to assign these values to an incrementing location of memories going from 0 up to 10. And so I ended up having to do this a pipeline of commands where the first command was NL. That's a Unix command called number line. And so what that really does, if you just look at it, is there. Because I needed something to get me an incrementing pattern. And that dash would be 0 right here. Means start the counting at 0. By default, it starts at 1. And so this gives us this counting thing. And then once we've got that, then we can start using our sed magic. So what we're going to replace is all of this with, you can almost see it kind of boiling down at this in our destination of where mem square brace /1, which is the first match, square brace equals 32 tick H /2, which is our second match. And so then if we start looking closer at what we've got here in our source area, is that we got this up arrow at the beginning, which is an anchor for the beginning of the line. We've got this /s star, which is any number of spaces, 0 or more. Then we've got the slash open paren / close paren with a /w star in it, which grabs a word, and that word in this case is this numbered index. And then we skip over any number of spaces, which are these spaces, and then we grab with this here, this /paren /w star /paren, which is grabbing essentially a consecutive sequence of words. Words are alpha nums, which would grab all of these words, and then it spits it into the output. So that little string, that command here, was enabled me to do, with one command, I could convert this format here into this format here, which I needed at that time. Actually, almost needed at the time. It ended with a semi. And so that is about all I can talk about with this sed. Hope you found it useful. It'll help me remember how to use sed. I get confused with /parens versus not / and other things. Signing off. Bye.